If you watched the first video that I posted about what it means to be a vector, I ended the video discussing the fact that you could be given an initial and a terminal point to situate your vector, to show kind of where your vector is located in space specifically. And what I've got here are 2 points given to me, but they don't tell me verbatim which one is initial and terminal in the sense that they're not labeled that way directly. But what I want to draw your eyes to is this little statement here. With this little vector hat at the top especially, it's really helpful. Although, what I did not mention in the last video is that if you're reading printed material, they often have a different way of notating vectors. They'll say that they'll use a bold letter for C and D instead of a little arrow. When you're writing things by hand, it's really hard to show things in bold. So we use this little kind of half arrow to show that it's a vector. But what they've done is they said C to D. They've listed it in the order that you want to work with it. So the first letter is always going to be your initial point. So C is going to be our initial point, and the second letter D will be our terminal point. And hopefully terminal, it sounds kind of like terminate, so it should kind of make sense. If you don't feel comfortable with the word terminal, if it feels weird, it just means where the thing terminates, where it ends. So we're going to go ahead and do a quick sketch of this. We're not going to get out graph paper or anything fancy because we don't need that. All we need is a general visual idea of what's happening. The point 4, -6, we're just going to pick a spot. Let's say that this is 4, -6. We'll call that C. Well, 3, 4, our terminal point, I know that 3 is to the left of 4 on a graph. So I'm going to come over to the left somewhere, and then 4 is above a negative number. Positives are above negatives, so I know I'm to the left and up somewhere. I'm not going to draw this to scale. There's no reason to. So C was at 4, -6. D was at 3, 4. And I get to be a little sloppy with this because this is just a sketch. I don't need anything fancy. What I do need is to be careful about the direction that I draw this in. So I'm going to rotate my paper just a second. It feels a little better to try to draw this way here. Notice again that we are going to call our vector CD in this direction. We're going to move from C out to D. What that means for my magnitude is that I'm going to be working with this right triangle here. Now it's not drawn to scale, so my triangle is going to look very different than yours if you use graph paper to kind of mimic this. Really, I guess I should point out that direction won't actually affect us too much. I started to talk about direction being important, but all we're going to do in this problem is find the magnitude. And so, since we're going to square the side lengths of both sides of this triangle eventually, the negatives I'm about to write down for some things won't matter in the long run. And so you can tell this is not drawn to scale at all, because our horizontal component is from +3 to +4. This would be a distance of 1 down here. And here we're going to go from -6 up to +4. That's a total distance of 10. So you can tell my triangle's drawn really poorly. They look like they should be flipped, basically. But that's okay. This is a sketch. All I need to know is that this is a triangle with a right triangle with a side length of 1 and a side length of 10. And they have asked me to find the magnitude of this actual vector. Well, that's just the Pythagorean theorem. In our previous video, we made this notation. We said vx squared plus vy squared equals the magnitude of your vector v. Well, in this video, v is just this CD. Vx and vy are the 10 and the 1. This is just the Pythagorean theorem if I actually put the square like I'm supposed to. So here, CD, its magnitude is just going to be the square root of 10 squared plus 1 squared, which equals the square root of 101. And for me, I'm just going to leave it as the square root of 101. That's a very nice value. If you go in and use a calculator, you'll get something like 10.05, I think is what I saw in the past with this number. If a problem asks you to round, do what they ask you to do. I like simplified radicals. This is perfectly fine with me. There's nothing else to it. It didn't give you units, so we don't have anything to adjust for here. And it did not ask for direction, so we don't have to worry about finding our angles.